Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps for the world's best companies as quickly as possible. So in this lesson, we want to start with the process of dissecting this first tiny little application that we created. I want to spend a few moments to look at every line of code in this file, this program.cs file that you see here in the tab name, as a basis for future exploration in C#. So first of all, let's take a quick review of what we did in the previous lesson. First of all, we used the Visual Studio IDE to create a new Hello World project. And then we wrote code in the area that was defined by those two curly braces. We made some space for ourselves and typed in 2 lines of code. And then we ran the application by clicking on this little start button here up in the toolbar. And this opened up a Windows command line window, the console window. Our application appeared. It was simple. It was just the words Hello World displayed in that window. And I didn't point this out, but you can use the Enter key on your keyboard to actually move past that pause in the application and let the application continue on and exit out, all right? And at which point that Windows command line window just disappears. So I hope you can see how your actions when writing and building the application are manifested whenever you ran the application and interacted with it. But what I really want to do is cement these ideas in your mind, because they really provide the basis, the foundation, for everything that comes next. So let's start from the inside, the code that we actually wrote, and work our way outside. And so we used a programming language called C#. There are many programming languages in the world, but at this moment, C# is one of 2 popular programming languages used to create .NET applications. C# is one of the main programming languages that Microsoft supports in Visual Studio. And so I'd highly recommend that you learn as much about C# as you can over the coming days and weeks. It's probably your best choice as you're getting started. Now, most developers aspire to master one programming language when they're first starting out. But once you master a single programming language, learning a second and a third language will be easier, because many of the concepts will transfer over, even if the syntax is just a little bit different. As someone who has been writing applications for over 20 years, I can assure you that C# is a great programming language to start with. So when you learn how to write applications with C#, learning the syntax of C#, or in other words, the nouns and the verbs and the punctuation of the programming language, is just half of the battle. The other half of the battle is learning about related pre-built functionality available to the programming language. In our case, Microsoft has created something called the .NET Framework. And while that sounds mysterious, it's actually not that bad. For now, there are just 2 parts of the .NET Framework that really concern us. First, there's a class library, which is simply a library of code that Microsoft wrote to take care of difficult tasks so that we, as developers, don't have to worry about them. So there's library code to help with math operations, or working with text, or displaying things to the computer screen, or transmitting information over the internet, and a bunch of other stuff, okay? So that's the first part, the class library. The second part of the .NET Framework is called the runtime. It's also known as the Common Language Runtime, or the CLR. And it's just a protective bubble that your application lives inside of. And I use the phrase a protective bubble because the CLR, the runtime, takes care of low-level details so that you, the developer, can focus on what the application does and less about how to interact with the computer's operating system, its memory, its hardware, and so on. Furthermore, the CLR provides a layer of protection for the end user so that you, the malicious, evil software developer, you can't do much harm to the user's computer, at least not without their approval or their knowledge, all right? So for right now, it's the .NET Framework class library that I want to focus on. So when we typed in the phrase console.writeLine, we were using some code in that class library that knows how to display text in a Windows command line window. And all we have to do is tell it what we want to display, or rather, we just have to tell it the important part, okay? We don't care how it writes the text, we just care that the text gets displayed to the screen. And that's what we did here. in the first line. Okay, so let's focus back on this code. When I wrote this code, I made sure to emphasize that you must write the code in the correct place between the opening and closing curly braces. Otherwise, the application will encounter an error whenever you try to run it. We talked about that at length. The correct place was between that opening and closing curly braces, as you see on the screen. The curly braces define a code block, a block of code. So as you can see, there are several sets of curly braces. And you can think of this as a series of containers. I'm going to oversimplify for just a moment, and we're going to build on this definition later. But this innermost code block that's defined by these curly braces, they have a name. And the name of that block of code is main. That's the name of this code. And this code just so happens to be executed first when the application comes to life, when the application is executed. So let's not worry about those other words there like static and void and string and args. We'll get to all that a little bit later on. But this entire code block here, it defines something called a method. And a method is simply a block of code that has a name. Later on, you're going to come to realize that a method is much more than that, but let's just use that as a working definition for the next couple of lessons. The method has a name. So when you have a name, you can call that name and you can execute that block of code associated with that name. Again, more about methods a little bit later. All right, so the main method lives within another set of curly braces like you see here. It's a class named program. Think of a class as simply an organizational tool, a way to keep all of your methods organized. You put all of the methods that are somehow related together in a single class. Now, what do I mean by related? Well, that's up for you to decide. And as you get deeper into programming, you're going to come to understand the philosophies of writing code that will dictate where the code should reside. In fact, a class is so much more than just an organization tool. I really oversimplified it. But just like I said about methods, let's just keep it really simple for now. Let's just use that as a working definition for a couple of lessons until we get a chance to talk about creating your own classes a little bit later in this series of lessons. The main takeaway for now is that code is organized into curly brace containers. And you have some blocks of code that reside inside of other blocks of code. All right? So notice that the class program itself lives inside of a block of code. Here, let me highlight it. And it's called Hello World. Again, to keep things simple, just think of a namespace Hello World, as yet another way of organizing code. We're going to come back to this later, and I'm going to tell you more about classes, more about namespaces, but for now, just think of them as simple ways of keeping code organized. And remember that the methods that you create need to live within inside a class and a namespace. All right? All right, so let's take a look at this first line of code that we wrote. Let's investigate it even more. Console.WriteLine, open parentheses, close parentheses, open double quotes, hello world. At the end of the line, we have a semicolon. Great. Here we're actually executing a method, a name block of code that somebody else wrote. The method name is WriteLine. And the WriteLine method lives inside of a class named console. Okay? In fact, that second line of code that we wrote here is executing another method inside of that class called readLine. readLine is another name block of code that somebody else wrote at Microsoft. And both of these methods are organized into the same class named console. Right. So since both of these methods deal with interacting with the Windows console, it just makes sense that they're both organized and they live inside the console class, right? So both of those methods have been written by somebody else, somebody at Microsoft. So we're borrowing code, or rather we're executing code that was written by somebody else by merely referencing the class name and the method name. And then notice there is a little period between each of those, that little dot operator right there, okay? That's called a member accessor. In other words, we can access a member of the console class by using a period after the name of the class, then typing in the name of the member, or rather the method that we want to execute. All right, so next, both the WriteLine and the readLine methods have a pair of parentheses immediately following them. In the case of readLine, that's all we have, but in the case of WriteLine, we have something in between the opening and closing parentheses, okay? The double quotes tell C# that we're passing a literal string into the methods. In other words, we literally want those exact words to be displayed. As opposed to what, you might ask? Well, I'll answer that a little bit later when we talk about variables. The key idea here is that some methods can accept input values, such as a literal string in this case, which is then used by the WriteLine method to display to the console window. And we'll come back to the notion of methods in the future and passing in values to a method like we did with this hello world in the double quotes. Just know that whenever you see parentheses after a word, think method. A method is being called right now. Okay, a named block of code is being called so that it can execute. All right, so now let's talk about this little semicolon that may have caused some problems for some of you if you're not used to typing in C# code. You can see that it exists throughout the program here at the very top with some code that we haven't talked about, these little using statements. We'll get to those a little bit later, and then in the lines of code that we typed in. The semicolon is similar to the period at the end of an English sentence. It completes a thought in C#. Some programming languages like Visual Basic, for example, they allow one thought per line of code, but with C# you can organize multiple complete thoughts on a single line by just adding the semicolon between them. So we could do this and our application would still execute, all right? But it's harder to read that way, so we generally put these on two separate lines. It's also possible to take a single thought and to break it up into multiple lines. Now, these lines of codes are so short that it really doesn't make sense to do that. But as we get to some longer lines of code later on in this series, you're going to see me break up one single line of code into multiple lines so that it's easier to read. And so, as you can kind of see, the line breaks and the white space. You know, here we can add all this white space here. They really don't matter to C#. It's really the semicolons and the curly braces that matter, okay? So notice that there is some indentation to our code. Kind of by default. I mean, Visual Studio's IDE, the text editor will kind of lead you in that direction. I mean, if you try to like write a line of code way out here, console.WriteLine, and then if I hit notice that it automatically indented it all the way over to several tabs over. This is completely optional in C#, but it's so important that the Visual Studio IDE will try to add it by default. Why do you suppose that is? Doesn't it make it a little bit more readable this way to see kind of the indentation level and see what code belongs to what container, whether it be a method, a class, or a namespace? Well, most people think so. I certainly do. So that's why Visual Studio does that automatically for you. Along those same lines, Visual Studio color codes the text that you typed into the code window. As you can see, class names are kind of in this aqua color, maybe green on your screen. Special reserved C# words are in blue, like static and class and void, and we'll talk about those later. String literals, like the word hello world in the double quotes, you can see those are in red. And so this makes your code more human readable. Okay, so expanding out from here, you can see that we're working inside of a file called program.cs. It's the label that we see on the tab at the top of this main area that we're working in. Now, if we look over here on the right-hand side, in this little window in the upper right-hand corner, we see it called the Solution Explorer. And it has a tree-like view of the items in our project or in our solution. So at the very top here, we have something called a solution hello world. And inside of that, we have another entry called hello world. This is actually the project itself. And beneath that, you can see that there are several icons here. If you were to expand those out, you would see other files and little icons and things of that nature. We're going to learn more about the Solution Explorer and the other windows that are available to us in Visual Studio a little bit later. But simply put, the Solution Explorer is our main navigational device to the other files and settings that once compiled together will make up our finished program, our finished .NET assembly that we can execute or put on somebody else's computer. Right? And so you can see here's that program.cs. If I were to close this window after saving the changes I made, I can open it up again by finding its entry here in the Solution Explorer and double-clicking it to open it back up in the main area. All right. So files and important settings are organized into projects, which are compiled into a single .NET assembly, an executable application. Or not. We'll talk about that later. Furthermore, one or more projects are organized into solutions. In many cases, as you're getting started, you're only going to have one project inside of the solution, but as you come to build more complex applications over time, it's highly likely that you're going to need to manage multiple projects that are related somehow. Okay. Again, the reason might not be obvious at this point, but as you continue learning C# and building more complex business-oriented applications for large companies, this becomes a crucial code management strategy. All right. So just for now, accept that there's this extra layer of solution owning projects, and trust me, it's important, but and it'll become more important as we move past the basics. All right. The big question at this point should be, where are all these files stored? I mean, I can see them in the Solution Explorer. Where are they on my hard drive? So, when you rely on the IDE to create a project, you have to live with the conventions that they use for setting up the solutions in the projects. And you do have the option to change it. We had the option, I ignored it in the previous lesson. Okay, so if you're using Windows 7, you'll see something under Libraries here on the left-hand side. And when you select Libraries, you'll see an entry for Documents here in the middle. In Windows 8 and later in Windows Explorer, you'll want to go to this PC and drill down and go to Documents, which is one of the options. And then you're going to see a folder called Visual Studio and then the year, or rather the version. In this case, I'm using Visual Studio 2013. You might be using something called Visual Studio 2075, like, 57 years from now, or whatever the case might be. That's fine. Just go ahead and click on whatever the latest one is that you're currently working with so that you can see inside of it. And there are a number of folders here that allow you to extend the IDE's functionality, but the most important folder is the projects folder here in the middle. So let's double click that to view its contents. And since this is the first time I've created a project, I only see one folder, the Hello World folder. And as I add more projects, they're going to be listed here and they're going to fill up this whole area. Let's double click this Hello World folder to view its contents. And inside, you're going to see another Hello World folder, as well as a couple of files that are named hello world dot something, like in this case hello world.sln, hello world.v12.suo. So the second Hello World folder actually contains the project itself. What this file is, this hello world.sln file, is the solution file, which is simply an XML file that contains settings that were stored by Visual Studio. So let's dive deeper. We're going to click the Hello World folder, the project folder, to view its contents. And so you can see a number of folders and files inside of the project. Some of these might look familiar if you compare them to the Solution Explorer. That's because you saw them in the Solution Explorer. Additionally, you're going to see a file called hello world.csproj, or a C# project file. It too is an XML file, and it contains important settings that are used by Visual Studio and eventually by the C# compiler to actually create a .NET assembly, an executable version of our application. All right, so just out of curiosity, what I want to do is open up this hello world.csproj file in Notepad, and I just want to view its contents. I certainly don't want to make any changes to it. I just want to open it up and take a look at it. So what I'm going to do is I'm going to right-click the Hello World project file and then click Open With. And when I do that, you're going to see this little dialog box. First of all, and this is so important, and please don't miss this, deselect this, because you do not want Notepad to open up to be the default application that opens up CS project files from now on. You will curse me if you forget this step, okay? I'm going to click More Options and find Notepad. It's usually listed there, More Options. And now I can open up this Notepad, this Hello World project file in Notepad. Notice that what we see inside is a bunch of XML, and XML stands for Extensible Markup Language. It looks a lot like HTML because it's tag-based language. It's frequently used in the software development industry as a means of adding configuration settings to an application, or in this case, to a project file. So this is sometimes known as metadata. This file contains file paths, the previous state of the project, for example, which windows were open the last time we had it open in Visual Studio, and a lot of other important settings. And I can't emphasize this enough, do not make any changes in this file. Doing so might corrupt the project beyond repair. All right, truth be told, this Hello World app, we could throw it away, but never mess with this unless you know what you're doing. And at this point, I don't even know what I'm doing, so I don't touch these sorts of things, and you shouldn't either. I just wanted to demonstrate that there's no magic really going on here. It's just a bunch of configuration settings that comprise a project. And the same is true for a solution. It's just at a little bit higher level in the hierarchy, a collection of projects that work together. Okay, so what I want to do is close Notepad. Do not save any changes you may have accidentally made if you put your elbow on the keyboard or your cat ran across it while you were looking at this file. Don't save those changes. Okay. All right, so back in Windows Explorer, the Hello World project folder contains this bin directory. And the word bin is short for binary, denoting the binary executable output that was created by the compilation process. If you open that folder up like I did, it'll reveal its contents, and you should see a debug folder, debug directory inside of it. So when you click the debug button, or the start running button rather, here on the toolbar, behind the scenes, Visual Studio compiled your application into what's called a debug version. The debug version contains additional information that allows the Visual Studio IDE to keep track of what's currently happening inside of that program as it's running. And as you'll see, this is one of the most powerful features of the Visual Studio IDE. It's the integrated debugging environment that allows us to watch code execute line by line as a means of determining where problems with our code might reside. We'll talk about that more later. Very cool and important feature. All right. So at some point, I want to release, create a released version of our .NET assembly that I can put on other people's computers and let them run my Hello World application too. And we don't want that released version of the application to be bloated with all of the extra information that Visual Studio needs when trying to do that debug choreography between Visual Studio and the running application. So therefore, we create a release version of our code, like we'll do in just a moment. But for now, what I want to do, go back here and click this, double-click the debug folder to see its contents. All right. So inside, we see quite a few files. The most important one is this hello world.exe program. Now, depending on your configuration of Windows 8, and the Windows Explorer, you might not see file extensions like I have here. I think what did I do here? Viewed options. I don't know what I did. All right, but there's a way in Windows Explorer to change the options, the view options. It's here it is. And so I made sure to deselect hide extension for known file types and clicked OK. All right, so, and then make sure you do that for all files or all folders in your in Windows if you want to see it this way. If not, take a look at the type column over on the right hand side. Make sure that you're looking at the application, not one of these other files that are named almost identically, except they have another little word like .config on the end of it. All right, just a little tip there. But these other files have various jobs, mostly related to that process of debugging. In other words, to keep the Visual Studio IDE in sync with the code that's currently being executed inside of that assembly. And we'll see that in action in the next lesson. Hang on. Okay. But the key idea, however, is that this is the debug version. It's not optimized to be released to an end user's computer because it contains all this extra stuff that's used by Visual Studio for debugging purposes. Ultimately, we're going to want to create a release version of the application to distribute to our end users. More on that in just a moment. So let's do this. I'm just going to double click this hello world.exe, making sure I'm clicking the one that says type application. So double click it, and whoa, there it is. It's running again. So even though this is the debug version of the application, you can see that the application can be run independent of Visual Studio. So just press the enter key on your keyboard to allow it to continue and to exit. So again, when we run from Visual Studio will be able to keep in sync and even peek inside the execution of the application and allow us to see which lines of code are currently executing and perform debugging. Again, more later. Okay, so what if we wanted to create a standalone version of our application that we could give away to somebody else? Well, once we've finished writing and debugging and making sure that our application works just right, then we can create a release version of our app. So back in Visual Studio, there's a little drop-down box containing 3 entries here. Whoops. Yes, here we go. There is the debug, the release, and the configuration manager. All right, so clearly the debug creates a debug version of the application. We saw the folder that it creates in Windows Explorer. Here's the release option. It creates the release version of the application. And then this configuration manager option, let's go ahead and click it. It opens up this dialog that allows you to create different configurations. And this is applicable whenever you have multiple projects in the solution and you want to mix and match between debug and release versions for each project, or you're targeting different platforms. For example, the x86 platform versus the x64, 64-bit platform. That's a bit advanced for right now, so let's just ignore that. Let's close that window and get out of here. So what we want to do is choose release, okay? And then what I want to do in the build menu is select build solution. And so this will create an executable for the configuration that you've selected, in our case, the release configuration here. You see, without actually running the application afterwards. All right, so in the lower right-hand corner, you can see these words, build succeeded, assuming that you've introduced no new errors into your code since we last talked. So now, back in the Windows Explorer, let's go back up a level, and you see a new folder called Release. Let's go ahead and open up that folder, and whoa, you might be surprised to see that many, if not all, of the same files are here. I thought we were building a streamlined version for distribution on other people's computers without all that extra stuff that Visual Studio needs to keep the debug version in check. Well, the truth of the matter is that in these simple examples for the console window applications, the output will be identical between the release and debug versions. When you get into advanced scenarios, you have the option as a developer to conditionally compile certain code based on the configuration that you've chosen. How and why you would choose to do that, again, sorry, a little bit more advanced topic. Let's just not talk about that for now. Just be aware of the difference between the debug and the release versions of the applications for now, and you know how to create each of them. Okay, whew, we covered a lot of ground in this lesson. So I just want to recap what we've talked about. First of all, we talked about the code that we wrote in our previous lesson. We talked about the organization of the code, how code is organized within curly braces. Those curly braces represent a block of code, a code block. We added code to a method code block called main, which is executed automatically whenever the user runs our application. Methods are organized into classes, and classes are organized into namespaces. And we also saw how we used methods written by Microsoft to work with the console window or the command window. In fact, both methods that we used, the writeLine and the readLine method, were organized into the same class, the same console class. And we accessed the console class's methods by using the period or the member accessor operator to access the member methods of that console class, at least 2 of them here, okay? We also passed in a literal string, the hello world string, enclosed in double quotation marks as an argument to the writeLine method. Now, we don't care how the writeLine method works its magic. We just care that it can display in a console command window whatever we tell it to display, in this case, hello world. And we talked about the syntax of C#, specifically the need for the semicolon as an end of thought punctuation mark for a C# statement. We also talked about about lines and spacing and indentation and how these don't really affect the code per se. However, they make it easier for we humans to read the code and understand what's going on. And likewise, we noted how the IDE's code editor uses color to further assist in the readability of our code. Then we used the Solution Explorer to understand the organization of the code files. We talked about projects as a means of collecting all the files and other settings required to generate a compiled .NET assembly. And we briefly explained how multiple projects can be managed under a single umbrella of a solution, thus the Solution Explorer window that we looked at as well. Finally, we talked about where you can find all the files for your project, as well as the file structure for the compiled versions of the debug and the release versions of the .NET assembly. So the good news is that you're well on your way to learning .NET and C#. Some of the more tedious aspects, honestly, are already behind you. And now it just gets a lot more exciting from here. So next we're going to review the basic features of the Visual Studio IDE that we've been using, and then we're going to move on to expressing more logic that we can add to our programs in C#. All right, great. We'll see you in the next lesson. Thank you.